Today, we are going to talk about patterns and practices for data integration at scale. My name is Anand Subaraj. I'm a principal program manager in the data group at Microsoft. I have with me Gaurav Malhotra. He is a senior program manager in data group as well. And this session, we plan to go talk about evolving approaches to analytics. Then we'll look into some of the data integration architectural patterns for both stream and batch analytics. We'll look into some of the use cases and show some cool demos. That said, let's get started. So I'm working in the data group for about 8 years now and have seen this, the data platform and data analytics in general, evolve in the last few years and go through a huge fundamental shift. And one of the good things about our role in Microsoft is that we get to work with a lot of customers. And a few years back, as a data integrator, when I would sit with customers to create their data integration solution, the pattern looked something like what you see on the screen now. It used to involve few sources. The goal was to connect to those sources, extract the data, perform transformation, load that into EDW. The goal of the transformation was to get the data, adhere to the schema of the enterprise data warehouse so that it can be leveraged for insights. And always, when we started in such problems, we used to have a piece of paper or a document that exactly described the scenarios and requirements that the customer had. The things have changed, and in the last few years, this happened. The number of sources and the volume of data have grown tremendously. And it's not just that, the business mindset is also evolving based on agile and dynamic requirements. Businesses now do not always understand upfront what are the scenarios and use cases they have, as this is also evolving. So the goal of data integration is to connect to as many sources as possible, collect data obsessively, so that you have the data in the rawest format that can be leveraged for transformation, refining, and addressing questions and scenarios as they come up. And this led to the evolution of the Hadoop ecosystem, which provides cheap storage so that you can store the data in the rawest format. The industry calls this as data lake. But the idea is to get the data in the rawest format so that you can use that data to perform transformation, refinement, as the new use cases come in and address those scenarios. It's not just that, right? Like, as you see this, with this pattern, the life of data integrators have changed a little bit. There are new set of tools, new challenges, new patterns and practices. And also what we have learned based on the customer interactions in the last few years is that it's not an either-or scenario. Most of the cases involves a heterogeneous architecture and ecosystem, which involves both the pictures that you see on top and the one in the bottom. Most of the customers still manage their list of products, list of customers, and other relational information, say in an on-premises EDW. But the new fact data, if you will, the data that's coming from applications, from sensors, from logs, from devices, they are being managed using this newer infrastructure. And it's kind of an augmentation of both the EDW that you have on premises and this new infrastructure. So as I said, from a data integrator's perspective, it's a new set of tools, new challenges, and new patterns and practices. And it involves a lot of expertise, a lot of tools, a lot of resources to address this at scale. And this is exactly what we are trying to address with the Cortana Intelligence Suite. You may have already seen this in several sessions. I'm not going to go into details about each and every component of the suite, but the idea is that we are providing a platform, we are providing integrated set of services that enables organization to transform data into intelligent action. So from a data integrator perspective, we are providing the set of tools to create the best of breed data integration solution to not just transform data into intelligent action, but also to create intelligent applications. So now what we are going to do is look into some of the data integration architecture patterns, and I invite Gaurav to take you through this.
Thank you. So we heard from Anand how the analytics is evolving. So how the volume, variety, and velocity of the data is changing, and what it is doing is bringing up different use cases for the customers. So the first pattern that we want to look in the data integration space that we have seen with a bunch of customers is the batch pattern. So the easiest way to understand the batch pattern is that you have data at rest and you want to transform that data at rest into intelligent action. One of the things that a bunch of you must be doing already in your organizations is that you are building smart applications. And you want those applications to get intelligent over a period of time. A classic example of that would be that you have a machine learning model and you are continuously retraining that model so that the next iteration uses a better version than the previous one. So this is a classic example of a batch pattern. Typically, in a batch pattern, you would see 5 stages, as you can see on the screen right now. So you have the ingest stage first, and here you are ingesting the data from different sources. And these sources could be on-premise or they could be in the cloud. They could be Microsoft sources or non-Microsoft sources like on-premise SQL Server, or it could be Teradata, DB2, Sybase, or it could be cloud sources, which can again be Microsoft and non-Microsoft like Azure SQL. You could be pulling data from Amazon S3, Redshift. So the first step is to ingest this data into the cloud, and that could be Azure. And the second step after you have ingested the data is that you want to prepare the data. You want to clean the data. You want to combine the data. And after that, you want to analyze the data. So you want to run some sort of aggregation or even a machine learning algorithm to do some sort of prediction. And eventually publish the data so that it can be consumed by your BI apps. And for each of these stages that you can see in the batch pattern, Microsoft today provides different services in the Cortana Intelligence Suite. And there are certain services that are available in the OpenStack as well, which you could use in an organization to achieve these different stages. The data ingest can be done by a simple SSIS that you could install on a VM in Azure, or you could be using an on-premise SSIS implementation that you got with the SQL Server. Or you could be using Azure Data Factory, which is a managed service in the cloud and has a globally distributed data movement service that allows you to ingest data from these multiple sources. For the prepare step, you could be using Hadoop. So before the prepare step, you're actually storing the data in some sort of a cloud storage, and you could be using Azure Data Lake Store, or you could be using Cassandra. And once you have stored the data, you are essentially preparing the data, and you could be using a Hadoop cluster for doing that. So Hadoop comes up with different SERDES that you can be using for cleansing the data. You could even use Azure Data Lake Analytics and run USQL queries to cleanse your data. Once you have prepared the data, you can again analyze the data using Hadoop, where you could be running a Hive query, a Pig query, a Spark job, or you could be running a machine learning algorithm that you have come up in the Azure machine learning stack. And once you have essentially done all of these steps from ingestion to prepare to analyze, there is a service that we have called Azure Data Factory that goes across all these steps and allows you to compose big data pipelines, allows you to schedule those big data pipelines across all these services, and allows you to monitor that. And in the open space, if you were to think how Azure Data Factory compares, there's Oozie that exists in the Hadoop platform, which does the similar function. And once you have essentially built your pipelines, you've operationalized that, and your data is ready for consumption, you could be using a very simple Power BI dashboard, or you could have custom BI applications that you could be using in your organizations, which are using the APIs that we provide. So with this batch pattern, let's look at one of the common examples that we have come across. And we have this, it's called customer churn. And a very simple way to understand customer churn is that you have customers who are about to leave your platform. So if you can identify those customers, then you can essentially run personalized campaigns for those customers to make sure that they do not leave the platform. Customer churn solution essentially was very common in the telecommunication industry because people would switch from one carrier to other due to cost, due to number portability that was introduced. And it's also common in the banking and retail industry. But there's a very interesting pattern that we have seen that it is being used, a variation of customer churn is being used in the education sector, where we are working with a bunch of schools, and I can name a few. There's Tacoma Public School in Seattle. We are working with Andhra Pradesh University in India, who are using a variation of customer churn to predict dropouts. So you can imagine that how useful that would be if they can do that. So this customer churn, if I were to explain you from an analytics standpoint, and if we were to understand the different moving pieces in the customer churn solution, so there are call log files, and this is from a telecommunication industry standpoint. So these call log files are essentially called CDR records, call data records, and you have some customer information that could be residing in an on-premise data mart. And again, it could be Oracle, it could be SQL Server. So the first step is that you want to ingest these call data records and the customer information into Azure. And it could be, again, Azure Blob Storage or Azure Data Lake Store, depending on your requirements. And then you want to essentially do some transformation and generate the customer call details, where you could be joining the customer information with call log information. And finally, you are analyzing the data, and you are running a machine learning algorithm to predict the customers who are likely to churn your platform. Now, this algorithm you have already built in Azure Machine Learning, and once you have the information about what are those customers who are likely to leave my platform, you can move that information to a relational data mart like Azure SQL DW, from where you can consume using a Power BI application. And your Power BI could also be integrated with Cortana, where you could use our natural language processing capability to ask direct questions. So in terms of big data pipelines, these customer table and call log files are data sets. And data set is nothing but a logical reference on top of the data. These steps from transformation to analyzing their data to moving their data, these are called activities in the big data world. So it's a processing step that you are taking. And a combination of these activities, a logical grouping of these activities is what we call as a pipeline. So now and again, you can basically see that how each of these steps are related to the batch pattern and the different stages in the batch pattern. So now we can go and look at how you can use today Cortana Intelligence platform to build these solutions. So what I'm going to do is that I'm going to go and build the customer churn solution. And this is just one example. You would be able to quickly see that how you can use this example to build other use cases as well. In order to build this use case, I'm going to use a service in Cortana Intelligence, which is called Data Factory. We already talked about Data Factory when we were looking at the batch patterns in terms of data movement and in terms of operationalizing your data flows. So Data Factory today is live in the Azure portal. It is under New Intelligence and Analytics and Data Factory. So you can provide the name, you can provide the subscription, you can provide the resource group. It's just a way of grouping resources in Azure, and the location. So today Data Factory is live in 3 locations, but I want to make a very important point here. Data Factory is just command and control. It is neither a compute nor a store, which means that you could have your storage, you could have your compute, which could be Azure Data Lake Analytics, or it could be Hadoop cluster in Australia, and still build a data factory where you could build these big data pipelines in West US and still operationalize and orchestrate your workloads. So in the interest of time, what I have done is that I've already created a data factory and pinned it to my dashboard, and I'm calling it customer churn and with today's date. And what I'm going to do is that I'm going to go and build this particular pipeline. So in the interest of time, again, I have built certain components of this particular pipeline. So what we have with Cortana Intelligence Platform is drag and drop authoring. So essentially, you could drag activities. So we have an authoring canvas, and we have a toolbox, which is a list of activities, and you can drag and drop these activities on the factory floor. So you can essentially go and configure these activities and say that this is the name, this is how often I want to run this activity. This is the Hadoop cluster that I want to use. And with Data Factory, we provide on-demand infrastructure management, which means you can come and say that, here is my job, and you go create the cluster, the Hadoop cluster for me, run the job and tear down the cluster. That's what we call as on-demand. So you could do that, or you could come and register your own cluster if you wanted to. So in this case, I'm using a Hadoop cluster with on-demand characteristics, and I have said that I want a 2-node cluster. I have a storage associated with that particular cluster. Here's my Hive script that I want to run. We have IntelliSense here and all those goodness. Here's where I want this Hive script to be uploaded and the parameters that I want to pass to my Hive script. So people who are familiar with Hive, Hive has this concept of HiveConf, and you can parameterize your script so that for every run, you can pass a value to that parameter, and it would run for that day's worth of data. So here we have configured a Hive activity. So what I have already done is that we have some raw data, and these are call data records, which I have already moved to Azure. Then I have partitioned the data. And the reason why I have partitioned the data is because I want the downstream operations to only run on that particular partition. So it's going to generate something like this, so that every downstream operation runs for only that particular month and does not run on the entire data every day. So we partition the data, then I have some customer information. Again, I have a Hive script which I'm going to run to join the partition call data record with the customer information and have the merged customer information over here. And what I'm going to do now is I'm going to drag a machine learning activity, which is essentially going to go and predict the customers who are likely to churn. And in this case, what we have, again, you can provide a name to this activity. And what we're going to say is that this is a predictive analytics activity. So we're going to name it that. We're going to run it monthly. And this is an Azure ML endpoint. So you already have your machine learning experiment published in Azure ML, and you have essentially published that experiment as a web service. So that means from external applications, you can make these calls to this application, provide the input data, get the output, and then you can use that output in the downstream activities. So we already have this machine learning algorithm built, and all I'm doing in building these big data pipelines is that I'm calling the endpoint for that machine learning algorithm. So I already have this endpoint, which is just an HTTPS endpoint. I'm going to put that over here, and then the API key, which is, you can think of it just like a password to your API endpoint. And here, the moment I go, it automatically says that this particular machine learning algorithm has one web input and one web output. So these are essentially the inputs and outputs to that machine learning algorithm. So in Data Factory's case, these are the data sets. So you can see that how quickly I was able to connect the output of the previous step to the machine learning activity. And I'm just going to quickly define the output for this machine learning activity, which we are going to call as predicted churn customers. And we are just going to say that the output of this machine learning activity goes in this storage account at this particular location. And here you can see in the path, I'm using a custom identifier. So because my data could be partitioned in a different way that I would like, So it could be YYYYMM. So I'm just providing that custom identifier there, and I can provide the value over here. So I say apply over here, and now I can see that I have the input and output. All I have to do is go and specify these inputs and outputs to my web inputs and output in the machine learning activity. And at that point, I have this entire solution built. So I can go and name this pipeline now to say aggregate and predict customer churn. It could be a scheduled pipeline or it could be a one-time pipeline. In my case, I'm going to make it a scheduled pipeline, and I'm going to run it for yesterday. And at this point, it is ready to deploy. So I'm going to deploy this, and what it is going to do is going to register my connections. So connections are nothing but a connection string to your storage account, to your Hadoop cluster. It is going to configure my data sets, which is the logical reference on top of the data, whether the data sits in Blob, it is essentially data in Azure table. And then you have the pipeline, which is essentially a grouping of activities that we are running. So all the Hive activity, the machine learning activity that we have configured. So at this point, it has deployed successfully, and I can go here and start to monitor this. So this is another value prop of Data Factory. So we already have seen two value props. Actually, we have already seen the first value prop, which is configuring and building these big data pipelines. This is the second value prop where you can monitor and manage that from a single pane of glass. So right now, we just deployed this, so it's still in the process of configuring that. So again, I have already deployed this previously, and this is how the monitoring pane looks like. So you can see the entire graph of taking the raw data to partitioning and running a Hive activity and doing a machine learning activity downstream. You can look at all your executions. You can click an execution to see what happened for that execution. So in this case, this was a Hive activity that has been running. And you can see that we have all the logs over here for this particular activity. And if there's a failure, you can look at the logs. And if you wanted to rerun it, you can rerun it right from here. So very dense information that we provide over here. We provide you easy navigation and debuggability. And you can essentially, let's say, just want to look at all the failures that have happened in your data factory. So what we have in the system are views. So you can look at the recent activity window. So that means basically what has happened in the descending order of time, what has failed, what is running currently. So very dense information that is available here. And eventually, we would be giving you capability to create your own views as well. So you as a DevOps person just want to create a view for last 1 week and look at all the failures, you'll be able to do that as well. Then we have ability to create alerts. So you can essentially say that I want to create alerts on failures, and you can configure it from here and get email alerts today. We are working towards adding other mechanisms for alerting as well. So the third value prop that I want to talk about is the copy service that we have underneath Data Factory. I've already touched about that in the batch pattern. So this capability allows you to ingest data from multiple sources. So what we have is a copy wizard, and using this wizard, you can ingest data from all these multiple sources today. And we support, again, Microsoft, non-Microsoft, cloud, on-premise sources over here, as you can see on this particular screen. So you can use this wizard to set up the pipelines to do the data movement. And Data Factory is built for doing cloud orchestration at scale. So if you have gigabytes of data, you have petabytes of data, you could use Data Factory today to build these pipelines, to ingest the data, to do the transformation, and finally egress the data so that it can be consumed. With this, what I want to show next is go back to the presentation and talk about the next pattern that we have. And before we do that, as I mentioned, that there are a bunch of other use cases that you can use today Data Factory for as well. So we talked about the customer churn pattern, but there are different industry verticals where you could use different use cases. And apply Data Factory to do those use cases as well. A very common one is product recommendation in retail sector, where you're continuously looking at what customers are adding to the cart, what products are they buying, and providing those personalized recommendations. The next pattern that we want to talk about is the real-time streaming pattern. So to understand this, you can think of it as that you have a continuous stream of events, and you want to do continuous event processing on those events. And apart from that, you also want to raise some alerts or notifications as the data is coming in. So in order to support this real-time streaming pattern, Microsoft has a bunch of services. The first one is Event Hub. So Event Hub allows you to ingest millions of events per second. And once you have ingested the data, you want to analyze the data as the data is coming in. So you have Stream Analytics, which allows you to run SQL type queries. So if you know SQL, you can just write a query in Stream Analytics and analyze to see what is happening in last 60 seconds, what is happening in last 1 hour, and get those insights into the data. Again, for real-time streaming pattern, we have a bunch of use cases. Common one is smart grids, where a bunch of companies like Honeywell are using real-time streaming architecture to determine failures in their plants and so on and so forth. And connected car is also one of the classic pattern. And as we go forward in the presentation, we're going to show you a demo which uses this particular pattern and talk about connected car in detail as well. So back to Anand.
So we have seen now both the batch pattern and the real-time pattern. But when we discuss with a bunch of enterprise-grade customers, it's not just real-time pattern or batch pattern. What they really need to do is transform their business using data. And they're looking to leverage both batch pattern and stream pattern. And that's where the Lambda architecture pattern, as what the industry calls this, comes into use. In this Lambda pattern, you have a batch layer and you have a stream layer. And this diagram, you can see the stream layer on top, and you have the batch layer at the bottom. Now, the stream layer, we have seen all these different services. The goal is to ingest the data in real time, analyze that data in real time, and make it available in a serving layer so that you can drive your analytics. And the batch layer, you want to do richer analytics, rich insights on the data, and leverage things like HD Insight or Azure Data Lake Analytics to process that data at scale. Now, what we have seen is that there are many, many use cases, like customer churn, for example. It can also be applied in a Lambda architecture fashion, wherein you are looking into how many customers you're getting every day, like in real time. What are the fraudulent activities happening with customers? And then you leverage the batch pattern to predict customers who are likely to churn. What I wanted to do now is look into one of the use cases, which is connected car. We are seeing a bunch of car dealerships, automobile companies, and even insurance companies. They are now leveraging the connected car use case to provide best experience to their customers. And we'll look into a demo shortly. Now, I was looking into a bunch of articles, and one of the articles said vehicles or cars, they are the most powerful IoT device out there. And some other articles said 75% of vehicles are going to be connected by 2020. And they're connected in one of two ways. They either have a built-in modem that enables connectivity to the cloud, or the other one, which is more popular these days, is that there is a device which looks something like this. This is an OBD2 device. There are lots of companies who are actually selling these devices, including Samsung. I recently saw one of the articles where they are selling one of these devices. You connect it to the vehicle's diagnostic port. It starts emitting data. You collect that data, analyze that data, and provide best experience to your customers. Now here in this demo, what we are going to do is leverage a simulator that simulates vehicle data, and we ingest that data using Azure into the cloud and analyze that both in real time and in batch. Now, before I go into the demo, there are various different use cases which are enabled with the data that's coming in from vehicles. It could be fleet management, it could be getting vehicle health, providing real-time view of the vehicle health to the driver. It could be usage-based insurance. I was looking into Progressive, and Progressive have this plan, it's called Snapshot, and what they essentially do is provide their customers a device like this. They need to connect it to the diagnostic port, and their driving habits are categorized as high risk, medium risk, and low risk driving. If you're a high risk driver, you pay more premium. If you're a low risk driver, you pay less premium, and so forth. And there are other use cases that you see here, like engine emission control, performance remapping, eco driving, and so forth. Now let me go to the demo. So I have a dashboard here, and the story goes like this. Assume Contoso Motors is one of the car dealerships in Washington. They have recently leveraged the Cortana Intelligence Suite to gain real-time insights on vehicle health and driving habit. And this solution, in this view, there are like two different aspects. Everything that you see on the left side, it's real-time view of the vehicle health. And on the right side, it's data that is coming out from batch processing. And this is insights about driving habits. So Contoso Motors at this point in time knows there are these many vehicles which are on the road. And if I look into this, it just not only tell us about the number of vehicles, but also different characteristics. It tells me that Bellevue has, which is a city in Washington, has most number of vehicles than another city in Washington called Sammamish. And it also gives different aspects of the vehicles, what makes, what models, etc. Not just that, Contoso Motors also knows at any point in time how many vehicles require maintenance. And this leverages Azure Machine Learning, and it tells Contoso Motors that these are the number of vehicles that requires maintenance at this point right now. And again, all these is cooked up data. Don't pay too much attention into the data itself, but in essence, it shows sedans require more maintenance than something like a small SUV. It also lists the VINs of vehicles that requires maintenance. And it also tells them that Redmond has more vehicles that require maintenance than other cities in Washington. And this kind of data can be leveraged by a car dealership, automobile manufacturer, not just to understand, do predictive maintenance, but also to leverage this data to do personalized marketing campaign, provide alerts and notifications to the drivers when they're driving the vehicle, and also do demand forecasting of parts because they know exactly what are the models of vehicles that require maintenance. And a lot of the automobile manufacturers, they are integrating this kind of data with CRM data, so they not only know VINs of vehicles, but drivers who are driving the vehicle. Now, a lot of time when you're driving your car, you get a red light on the dashboard, and at least myself, that is the only time when I look into the manual and see what's going on. But think of a scenario where you get this red light turned on, and you get a message in an accompanying app or from the car dashboard which tells you that your oxygen sensor is low. You need to take the car for maintenance in less than a week. And the servicing department, they also know about your information, and they know that you're going to come in about a week. And all these experiences become much more personalized and improved experience for customers. And that's exactly what automobile companies and car dealerships are trying to accomplish. Now, we have seen the real-time view. Let's look into the batch views here. The aggressively driven vehicle. This one is interesting. If I look into this, I know that, as expected, sports cars are more aggressive than something like a compact car. It tells me Seattle has more aggressive driving than other cities in Washington. It also gives me an interesting pattern. It tells me that summer to the end of the year has more aggressive drivers than the winter. And it always rains in Seattle, so probably people are driving carefully and slow. And the aggressive driving pattern that we are using here, it's very similar to what Progressive is using, for example. Here, we are looking into drivers who are driving fast. If they slow down within a specific window, like say 7 seconds, we consider that as an aggressive driving. It goes as simple as that. And again, this is like not comprehensive, does not cover all the use cases, but gives a good view of how you can leverage the data that comes out of your vehicle. It's the same set of data. You want to use that data in real time for doing real-time analytics, providing alerts and notifications to your customers and also to your departments, various departments that get notifications, and use this information in batch processing to provide richer insights for your company and also for the customers. Now, going back into the deck, this pattern exactly would look something like this, right? Like again, like I have to repeat a little bit what I mentioned earlier, the data coming in from the simulator or from the cars, it can be ingested using Azure IoT Suite, IoT Hub. We provide capabilities that allows customers to connect to their devices and get the data into Azure, do command and control to the devices itself, or use Event Hub just to get the telemetry data for analytics. You can leverage both Event Hub and IoT Hub in this case for connecting to the devices. Now, after you have gotten the data, you use Stream Analytics. In this case, that's exactly what I'm doing. I'm using Stream Analytics for two things. One is to spool the data into a long-term storage. In this case, I'm using Azure Data Lake. You could leverage Azure Blob Storage as well, which is your data lake, which is the place where you're storing this data in the rawest format for doing batch processing. And in the real-time processing, I'm also using Stream Analytics to run real-time queries on this data and show the real-time insights in Power BI dashboard. The data from Stream Analytics is also going into Azure DW here, which is my serving layer. And on the batch side of things, I leverage both HD Insight and Azure Data Lake Analytics to process this data at scale so that I can get the richer insights and analytics on this data. And one of the interesting things, we are using machine learning in two ways. One in the real-time aspect, wherein we are doing a prediction in real time by leveraging the integration that machine learning has with Stream Analytics. And the predictions that you saw there, it's exactly the outcome of that particular flow. On the batch side of things, we use machine learning for continuously training the model so that we can make this model and the application more intelligent over time. And all the data from the batch processing also gets stored into SQL DW for gaining insights on this data in Power BI or other applications. And we provide APIs on all these layers so that like, you can really integrate your line of business applications if you wanted to do that. A couple of things I wanted to quickly go over. One is the data factory. You saw the data factory before. It looks like the session timed out. I'm not going to go detailed into this particular data factory, but this shows the batch layer wherein the data is in Azure Data Lake or Blob Storage. You want to process the data and transform the data and then make this data available in your data marts or data warehouse for insights. So you'd be leveraging Azure Data Factory and orchestrating such workflows. Gaurav showed you a detailed demo of how you can leverage Azure Data Factory in this case. So I'm not going to drill down into this, but the idea is that you are able to orchestrate the entire batch processing with Data Factory. Now on the real-time processing, we use Stream Analytics, and this is the Stream Analytics job that I have. It has few inputs. The data that's coming from Event Hub is one of the input. I'm also using data that's sitting in a Blob Storage or Azure Data Lake, which is a reference data. In case of this particular demo, I have the fact data that's coming in from the vehicles, but I also need some mapping data which maps VINs to vehicle models, and I'm doing a join between these two in one of the queries. And then it has the output. One of the output is Power BI, where the data is visualized in the reports. Now, if I go into the query itself, and it's few lines of code that you see, it's like SQL query, apology for it it's not very visible out there, but essentially this is like few lines of SQL queries that we have written to transform this data in real time. Now, what we provide with the Cortana Intelligence Suite is ability for customers who want to leverage open source. You could accomplish this Lambda architecture pattern using Storm in Azure and also using HD Insight if you are comfortable with the open source stack. So in essence, what we are essentially doing is providing both support for the open source capabilities and also managed service that we provide in Azure. Now back to the deck. So due to the interest of time, I could not go into details of this particular solution, but what we have done is this solution is available as a solution example or a solution template in the Cortana Intelligence Gallery. You can go there, deploy this entire solution in your subscription in less than 20 minutes. So you can go there, use your subscription, deploy this particular solution. We have a playbook with details about how we have built the solution. So you can go into this. It's now called solutions. It's no longer called solution templates. But in essence, you can go to the gallery, click on solutions on top, see a bunch of solutions that we have, vehicle telemetry analytics. That's the name of this particular solution. You can deploy that in your own subscription, go through the documentation and understand how we have built that particular solution, why we have used one pattern versus another, and so forth. And you can quickly build this and get this entire solution in your own subscription. Now, in the next few minutes, what we wanted to do is talk about different scenarios in the batch pattern itself. So what we did was we looked into batch pattern. What is batch pattern? We looked into real-time pattern. We looked into the Lambda pattern. Now we'll spend the next 5 minutes or so talking about a bunch of scenarios in the batch pattern itself. The first scenario is this notion of time series data and processing of time series data. This is one of the emerging patterns with big data. And what we have seen is like your data that's coming in from web logs, application logs, or sensors, they are always time series data, meaning they have time dimension in that. With Cortana Intelligence Suite, with Azure Data Factory, what we do is provide first-class support to process such time series data. Now, if you look at the diagram that we have in this, you can have data that is sliced by time, and this is non-overlapping tumbling window of data. Now, you want to process, say you want to use an Hadoop activity or HD Insight to process this data. The processing needs to be aware of the time dimension. And if you want to create an output, in this case, like you have a data, incoming data, you process that, you produce output, the output also needs to be created for that time slice. So if you have your data, that input data that's coming in daily, your output data may also be daily. Now, this is a very simple example that we have provided, but we have seen customers who have different kinds of variations here. Now, your input can be hourly or output can be daily, or your input can be daily and output can be weekly, and so forth. And when you process this data, not just process, but reprocess or restate this data, that also needs to take into account the time dimension. You can use Azure Data Factory, you can use the Cortana Intelligence Suite to handle such scenarios at scale very effectively. We have seen a bunch of customers. We have a major telco company who is leveraging this pattern for their customer churn. We are seeing a bunch of customers in automobile industry who use this pattern and so forth. Now, the next scenario is custom flows. In most of the organizations, time series is not just the only scenario or pattern that they address. They want to address different data types, different dimensions of data, and so forth. So this pattern, custom flow, it enables organization to just orchestrate standard workflows. If you are familiar with SSIS, you have control flow and data flow. Think of the control flow aspect of things, like wherein you may want to kick off a particular workflow when an event occurs, when a data arrives. It's not always based on time. And during the processing, you may want to do conditional branching. You may want to perform something on success. You may want to perform something else on failure. Maybe you want to integrate with your ticketing system when things fail. Now, with this custom flow, all these different flexibility is provided in the object model or the app model that enables organization to address all these different flows. Now, the next one is the scenario of data migration. We have seen a lot of customers, they're either trying to lift and shift their on-premises data into cloud, or they're trying to modernize their data warehouse and they're trying to move data in the cloud. Now, this usually involves few steps. It's a multi-step process wherein you want to first do a compliance check to see if your destination is compliant to the source. You want to move the objects, then you want to move the data, and it's just a one-time load. Then you want to do delta processing and so forth. So we provide tools. Our data movement capabilities are evolving to support such scenarios of data migration as well. Now, the next two scenarios that we are going to look into are variants of data migration or are sub-scenarios of data migration. Delta flow, this is essentially change data capture. You have some change, you do a one-time move, then changes happen, and you want to capture the change and move only the changes to the destination. Now, again, the system, Cortana Intelligence Suite, and Azure Data Factory, which provides the connectors to different sources. These are evolving to support such things, such scenarios. We are also working with few partners that will enable our customers to address such change data capture scenarios. And the last scenario that we have is, again, a sub-scenario of migration. This is referential integrity. What I mentioned is during migration, it's not just migrating the data, but migrating the objects and relationships between the objects. You may have foreign key relationship between object, and you want to sequence the data movement so that such referential integrity is preserved. This is another thing that we are evolving the object model and the underlying infrastructure to support. So in essence, we saw a large number of different scenarios and patterns. Some of these scenarios are addressed as first class in Cortana Intelligence Suite today. There are others that we mentioned here wherein we are evolving the system, evolving the infrastructure, and the app model to support. We have a lot of documentation in the internet. There are large number of case studies. We have several customers in various industries who are already in production with Cortana Intelligence Suite, who are addressing their organizational data integration needs with Cortana Intelligence Suite. So you can look into some of those case studies out there in the internet, in the Cortana Intelligence website. With that, we'll open up for Q&A. Any questions? Yes, please. Can you please come to the mic?
Yeah, sorry. The sample that you had said, the financial analytics portfolio alerts, is that one of the samples that's up on the solutions section?
Yeah, in the solutions, we have different kinds of samples. One of them is experiments. There are APIs and there are solutions itself. You'd see some experiments and APIs for financial reporting and financial identifying fraudulent activities and so forth.
Cool, thanks.
Any other questions?
Please go ahead.
Hi. So I have a question considering, like, from the DevOps perspective, the feature set that you showed, it was very impressive. Like Data Factory and Intelligence, the Cortana Intelligence. But from the continuous integration, continuous development perspective, is it possible to still maintain the command line, like Git-based repository of all the orchestration, and avoid the graphical user interface for those who prefer the command line?
Absolutely. The question is, do we support command line interfaces? How do you do continuous improvement or continuous integration if you would like to do that? So everything that you saw here, all the different services that we showed, it has a graphical interface and it also has a bunch of programmatic interface. One of the things that Azure provides is something called as Azure Resource Management ARM. And it enables you to create JSON-based configurations, if you will, and author all of these different components. The solution that you saw, the vehicle telemetry analytics or other solutions that we have published, this is all based on ARM, right? So if you want to do continuous integration, you can leverage ARM. You can also leverage Azure command line interface if you are looking to do your development in a non-Windows-based operating system. So we provide very rich programmatic surface area in all of the capabilities that you saw, especially on Azure Data Factory. We provide an ARM-based support. We have JSONs. We have a .NET SDK. And we have PowerShell. So you can use all of that to do continuous integration. In Azure Data Factory specifically, we also provide a Visual Studio interface. For customers who are trying to integrate with their source control, you can use the Visual Studio interface and integrate with your source control. Now, apart from all of these, what we are working on is a bunch of experiences to improve the whole authoring interface and the authoring ecosystem, if you will. And these experiences, as they are evolving, they'll have integration with Git, so that like when you're authoring stuff, you can integrate, you can push the changes to the Git, you can get the changes from the Git, and so forth.
And just to add to that, there are a bunch of customers already, particularly ISVs, who are using the programmatic interface. As you can imagine, that they don't want to use the graphical interface because they have their further customers. So it's a very common pattern that we see across a bunch of big enterprise customers as well as ISVs.
Go ahead.
Okay, so I guess my question is more concept-based around the batch processing as it relates to ingress from like legacy CRMs that live on premises. Can you talk to me a little bit about best practices surrounding moving that data in? I guess is the Event Hub something that's going to move the very large process of ETLing that data into the warehouse, millions of rows at a time, and things of that nature, into rather than once every 4 hours, for instance, moving that down to making it more practical to hit the database with smaller batches, things of that nature. Is there anything that this does architecturally differently with those sorts of legacy applications?
Yeah, it's a great question. The question is, if you have legacy applications, how do you do data integration with them, and what are the best practices and patterns? So one thing, we showed both the batch processing aspect and the real-time processing aspect. You would use Event Hub only when you have a real-time requirement, because this streams the data in real time so that you can do continuous event processing. In case of data coming in from a legacy CRM system, my assumption is that the requirement is not for doing real-time processing. It's mainly for doing batch processing. In that case, you would be leveraging Azure Data Factory and the connectors that we provide to move data from on-premises. Now, I would explain that in two different ways. We have a bunch of connectors to data stores that we already support out of box. We also provide a generic ODBC connector. So if you have a system that we do not have connectivity directly, you can use the ODBC head to connect to that particular source. Now, for on-premises connectivity, we provide a piece of tool. It's called Data Management Gateway. You can use that to connect securely to an on-premises environment and move data from on-premises into cloud on a continuous cadence. Now, we spoke about time series data and non-time series data. Assume your data in this case is time series. You have a time dimension to it. If you do that, then my recommendation would be to chunk that data based on time, get that data into Azure, and store that data partition by time. And once you have that, as you get new data, you can do incremental updates on that data. If you have a data set that does not have a time dimension, you would want to maybe do a one-time copy. And after that, you may want to leverage some kind of a triggering mechanism to trigger the changes from the on-premises into the cloud. And we provide tools that enable you to do that.
And just to add to this, as you saw in the slide, we talked about patterns where we talked about data flow, change data capture. So today, we are evolving the ecosystem to support those scenarios as well. But it doesn't mean that the customers cannot use the platform to achieve that. So we have seen a bunch of game studios using stored procedures to achieve change data capture. So we are evolving, but you can achieve those scenarios today with the platform as well.
Can you do like a time series aggregation and store it directly in Azure today? Like how you do it in Redis or some of the NoSQL databases? Can you use any of the Azure ecosystem as such to kind of do a time series aggregation?
Yep. So the question is, can you do time series aggregation and store the data into Azure? Absolutely, yes. We can discuss offline on how you can accomplish that. Any other questions? Okay, thank you so much.
Thank you so much.